Hi, I'm Dave Farley of Continuous Delivery and welcome to my channel. Welcome to this special compilation episode. This episode covers my most important tips for becoming a great programmer. This month we're producing a series of these compilation episodes to help us to manage our workflow at Continuous Delivery to make sure that we can keep producing great content and stay on top of our other projects away from the channel too. But we didn't want to leave you empty-handed. So we thought this would be a good way of keeping you satisfied until we can return with new, fresh content. Before we get to the first clip though, let me say thank you to our sponsors. We're extremely fortunate to be sponsored by Equal Experts, Transfig and Tuple. Equal Experts is a multinational consultancy built on applying the ideas and techniques that we talk about here to build great software for their clients. Transfig is a financial technology company applying advanced CD techniques to deliver low latency trade routing services to some of the biggest financial institutions in the world. Tuple build great software to make pair programming easier for people who work remotely. All of these companies offer products and services that are very well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, click on the links in the description below and do check them out. Now that's out of the way, I hope that you enjoy this episode and I hope to see you again soon as well. I've been fortunate enough to have worked with some world-class developers during the course of my career and met many others who are well known and well respected in our industry. I think that there are some common, maybe not universal, but common shared characteristics. I don't have any data to back these opinions up, so they are only my opinions, but here they are with my view on the 6 important characteristics of great developers. Number 1, code as communication. I think that when we think about writing code, we often imagine ourselves as communicating with a computer. And to some degree, that's clearly true, but it isn't our primary objective. Computers, unless you're doing something weird with quantum computers, talk in bits, on or off. So the most efficient way to talk to a computer from its perspective is to flip some switches. In fact, in the earliest days of computing, this is pretty much how things worked. Even as late as the 1970s, punch cards with holes or not holes represented the value of a bit. We've moved on from there. That's not how it works anymore. These days, the target of our communication when we code is other people, not the computer. Of course our code needs to work, but all modern computer languages are focused on how we think rather than how the computer works. Then they translate our ideas into an executable form that our computers can work with. This means that we should take care to communicate well. The readability of our code is not a nice to have, it's an investment that saves time and money. Often the person that you want to be able to read the code is you in the future. So good programmers spend time and effort in making their code clear. Code that communicates the ideas that it embodies effectively and concisely. A few tricks to achieve this are to pick clear descriptive names for modules, functions and variables. Pick names that allow you to make little sentences that make sense. Keep modules and functions small and focused on a single task. Aim to write code that anyone could read and then be able to understand what's happening in their narrow focus in just a few seconds. Next in my list is to be rather cautious of frameworks. Frameworks are useful tools, but they are ephemeral. They change all of the time and are not the core of our skills as professional software developers. This means that there are risks to using them. If the design and structure of your code is determined by the frameworks that you choose, that means that your code will need rewriting if the framework changes, or if you decide to migrate to another. This is often, maybe even usually, a big enough cost that it's going to put you off the move. So in general, we'd much prefer it if we could control the overall organisation of our code, allowing us the freedom to change it as our understanding grows, as our needs change, or as we realise that we made a mistake in our choice.
The problem is with this advice is that many software products make this difficult, if not impossible. There's a somewhat cynical view that this is in the interest of the framework providers to lock you into their framework. There's certainly truth in this, but at least for the open source frameworks, I don't think that is their primary motivation. Rather, it's that it's easier to imagine how to make people's lives easier with your great new framework if you place limits on the structure and programming model that your users need to employ. If you can force people to write their code that uses your framework in a specific way, then it makes your life as a framework creator simpler. This is so true that it is really what defines a framework rather than a library. My code uses a library, but my code is structured by a framework. So by definition, a framework imposes structure on our code. That tends to lock you in. I'm not suggesting that all your code should be so generic that it will work with any old framework. That's a big cost, not worth spending. Rather, that you treat frameworks with a degree of care. Think about the degree to which they force their programming model on you. Some frameworks ask less of your code, others more. I prefer the ones that ask less. How much of your code is framework specific is a good question to ask. How easy or not would it be to keep the core of your code, the parts that really define the value of your system, clean of any framework dependencies, for example? In general, I prefer frameworks with a rather light touch. In fact, I usually prefer to retain full control over the programming model and structure of my code, and so tend to pick frameworks or libraries that will allow me to do that. My preference whenever I can is to isolate any third-party code behind my own abstraction of its function. I'm not going to work hard to make that abstraction completely generic. It just has to stop the third-party code from leaking too far into mine. That way, I have just a bit more choice if I need to change my mind in future. There are times and technologies where this isn't possible, or at least too costly in terms of effort. For me at least though, I treat these sorts of frameworks with much more suspicion. I accept frameworks like this only if they give me something really, really important that I can't get any other way. Even so, I will try and limit the radius of their influence within my code as far as I'm able to. Next in my list, coding is designing. It seems to me that we often talk a lot more about tools and technology than we do about design. I was in a conversation with someone recently. We were discussing how to solve a problem that they had and how the system could work to deliver some feature. I was describing it in terms of the information in the system and how it flowed between different modules and the sorts of things that the modules would need to say in conversations between them. They kept translating it into features of Kubernetes and Helm charts. First, I'm not a Kubernetes expert. Second, that wasn't really what we were talking about. And third, it seems to me that they were confusing the accidental complexity that Kubernetes manages with the essential complexity of the problem that we were talking about solving. This seems quite common to me. Often, if I ask people how their systems work, most will respond with a list of technology that tells me very little about how their system actually works. It is the shapes of the solutions that we create that really matter, much more than the technologies that we choose to implement those shapes. How we choose to divide a problem up, how we decide where it makes sense to add some new behaviour to the system. I talk about this in my new book as focusing on managing the complexities of our system. And it is, but the other word for this is really just good design. I don't see any distinction between coding and design. Design is not the job of some clever person in an ivory tower somewhere. It's the choices that we all make every day when we write good code. The good is important here because there's quite a lot of code out there that has no visible design at all. This is true at the tiniest level of the code within a function and at the biggest of scales for some globe-spanning system. Design is the collection of organising principles that we choose to apply to the code that we write and the systems that we build. Those organising principles help us to compartmentalise the problem and manage that complexity. It's fundamental to our discipline, and more than any other characteristic that I can think of, it's the thing that distinguishes the great developers from the not so great. All of the best developers that I know focus first and foremost on the information that we are dealing with and how we deal with it in terms of the protocols through which information is exchanged between different parts of the system. They may not always think of it in those terms, but I think that's what they're really doing. How that maps onto the technology is a separate and ultimately a smaller part of the problem. Try to visualize what you are really trying to achieve without referring to the technology that you expect to use to achieve it. Draw a picture. It doesn't need to be formal. Talk about the ideas, use sticky notes or wave your hands around, but think first in terms of the shapes that you will need to create and the conventions and the conversations that they will need to do the job. Only then think about the technology. Next on my list of things, quality over features. Good programmers take pride in their work. This is not some gold-plated over-engineering. This is practical and pragmatic. They aim to retain and sustain their ability to make change effectively and efficiently over the long haul. Most software spends much more of its time in use than it does in initial development. Estimates comparing the amount of work in initial development to the amount of work spent keeping the software up to date and working after release range somewhere in the range from 60 to 80% in the favour of maintenance. This is probably even more skewed towards change after the first release if you adopt incremental approaches like continuous delivery and agile development. So that means that great software developers will optimize for that long haul. They will work hard to build high quality now because they know that that will reduce the likelihood of rework spent fixing dumb bugs in the future. And it means that when they need to revisit their code in the future, months or years later, it will still make some kind of sense to them. Next in the list, professional software development is a social activity. There was a study that I can't find a reference to. If anybody knows of it and has a link, please do let me know. But the study was meant to identify the characteristics of great software developers. The only common characteristic that they could identify in these developers that were categorized as great by their colleagues in the study was that these great developers talk to other people more often. Most professional software development is carried out in teams. Even if you are working alone in the code, you're usually working with other people that will describe the problems that they want you to fix. So software development is a social activity. So sure, there's probably some truth in the caricatures of us being nerds, at least for me, but they are overblown. The best software developers that I know are good communicators. Some of them are sometimes socially awkward in some contexts, aren't we all? But they can express an idea clearly and they can describe even complex ideas to other people clearly. This is importantly related to the first idea in my list, code as a communication. If you find it hard to express your ideas clearly in conversation or in a diagram, what are the chances that you're going to be able to write good code? There's a lot to this, and so a lot of ways to tackle it. It helps to teach others. You learn from that experience. One of the reasons that I value pair programming quite so much is that it forces us to have conversations about code and to learn from one another. You can say the same for code review. If you are struggling with a solution or an idea, go and explain it to somebody else. You'll be amazed how often you will solve the problem before you've even finished explaining it. Maybe try writing a blog. Even if a few people read it, it will help you to organise your thoughts, develop your writing, and so grow your communication skills. Collaborate with people on tasks at work. Offer them your help. Maybe join a user group or a meetup group that talks about things that you're interested in. Software development really doesn't thrive in a vacuum. The idea that a lone genius hacking away in a basement is largely a myth. There are times when you will benefit from working alone with some deep focus, but don't overplay it and try to find ways to often bounce ideas off other people. Next in my list, avoid code ownership. The great developers that I have seen are free with their ideas and usually open to having them criticised. They may not always seem like that at first. They'll defend their ideas vigorously, but will always be open to learning something new if you can show them. They are not precious about their code just because it is their code. I confess, this may be one of my more idealistic takes, but it's certainly true for all of my friends who I consider to be genuinely great programmers. In professional settings, I see it as an anti-pattern for an individual to own sole responsibility for an area of the code. At the minimum, responsibility for any given area of the code should be shared by the team. We want people to criticise our ideas. We want to be able to get new and different perspectives and different inputs. There may be one person on a team who is the go-to person for the keeper of a flame for any particular part of the system. But if they don't allow anyone else to touch the code, then that is certainly a problem. The last in my list, and in many ways one of the most important ones, is to work in small steps. The best programmers are generally very bright. They're smart people. They can hold a lot in their heads at the same time. They can discuss big, complex ideas, but they make progress in small steps, checking each step as they go. I believe that by far the best way to organise this is with test-driven development. But even when not, great programmers make a small change and then they check it. They are usually expert in the fine-grained skills of refactoring, making tiny changes that allow them to mould and reshape the code to suit their current picture. Working in small steps is one of the most important ideas in doing a better job in software, and optimising to get fast, high-quality feedback is the reason. If we proceed in small steps, we can learn more quickly. It allows us to proceed with more confidence, to explore our solutions, continually judge them, and so refine and improve them. So those are some of the things that I've spotted in the developers that I admire. If you have more suggestions, do let us know in the comments below. The approach to software development that I generally recommend rules out some ideas and practices. I think that's a good thing. I don't believe that all ideas have equal merit. If you believe the world is flat, you're simply wrong. I think that waterfall development is flat earth thinking for software development. It doesn't work, and it tries to address only some of the problems in what are fairly naive ways while ignoring others. This is opinionated. It is my opinion, but it's also backed by some evidence. If you look at data for the success of software projects, then waterfall projects fare badly in terms of efficiency, quality, and basic measures of success, like did it deliver what people really wanted? Now, waterfall proponents will argue that the data was probably collected wrongly and that the experiments were compromised in some way. But let's take a slightly more pragmatic view. Are there any organisations that we think of as doing a great job of software development that claim that this is the result of practicing waterfall? If I'm honest, I can't think of any. I picked waterfall as something of a straw man. But how do we reject bad ideas? Although I think that most people, if asked, would say that waterfall is discredited and no longer thought of as a sensible approach, my impression is that most organisations, at least implicitly, still think this way. So we can't even get rid of an idea that is as discredited as waterfall. There are lots of myths in our industry, so how do we bust them? I describe practices that sometimes challenge people's assumptions and experience. The consequences of ideas like continuous integration, continuous delivery, and test-driven development, when followed to their conclusions, are disruptive and challenging, but they work better. When I publish my thoughts on these ideas, I sometimes get pushback from people, which is fine, but I try to approach things from a more scientific engineering approach rather than just saying it's good because I like it. So what does it take to change my mind? First, if I recommend a practice here, that means that I've always tried an alternative. I certainly can't claim to have tried every alternative, of course, but I've always tried more than one. So yes, I have worked on projects that didn't have automated tests. Yes, I worked on projects that didn't have version control, continuous integration, or any of the other practices that I talk about here. And the reason that I talk about these things and not the others is because in my experience these things work better. As far as I can, I try to determine these things work better part based on two things. In addition to only my personal experience, is there evidence to back up the claims, and can I make a reasoned explanation of why this idea might work better than alternatives? The evidence part is easier than it used to be. These days we can look at the results from the State of DevOps report, a detailed survey of the performance of thousands of software projects based on 45,000 surveys over several years. Now you may choose to argue with the approach, but if we are to be scientific or even just rational in our thinking, then you need to present a better alternative. The State of DevOps is based on measures of stability and throughput. Stability measures the quality of the work that we produce, and throughput measures the efficiency with which we are able to produce work of that quality. Want to propose an alternative? Good. Then do the work and show your evidence for why your measures are better or your approach gets better scores in stability and throughput. You can't simply reject the findings based on personal experience or hunches. Well, you can, but don't expect to be taken seriously if you do. My second qualifying criteria is, can I form an explanation? This is part of taking a scientific approach to reasoning about these things too. It's valuable to have a model for why the things work the way that we think that they do. Then we can evaluate our ideas against our model, and we can test our model based on the evidence and experience that we gather by trying it out. For example, I think that continuous integration is better than feature branching. That isn't based on my personal preference. I've tried most ways of branching that you've probably ever thought of, and maybe a few that you haven't thought of unless you're prone to nightmares. But there is data that backs up my claim. And I think that I can refute arguments for feature branching based on a reasoned, rational model for how information changes when we have copies in two or more places. So let's try and apply this kind of thinking to some of the commonest pushbacks that I get about what ways of working better. Here are 7 common pushbacks that I see all of the time. The first is, you can't do serious work without feature branching. Let's start here. My views on continuous integration and feature branching are probably amongst the most contentious that I talk about. To summarise, I say you can't do both continuous integration and feature branching unless your feature branch lasts for less than a day. So try to put your personal preference on hold, just for a moment, whatever it might be. Continuous integration is about continuously integrating our changes together. What does continuous mean? Well, in the context of continuous integration, the experts and the definition of continuous integration say we should be merging them together at least once per day. So once per day is the bare minimum to qualify for continuous integration. What does integration mean? It means checking to see if our changes work together. That means everyone's changes. So it isn't continuous integration if you only pull your changes from master to your feature branch, even if everyone else is doing the same, because the changes you're really interested in are hidden away on your teammates' feature branches. You're not integrating with those. So what does the data say? Well, the State of DevOps data says that you create worse software more slowly when you feature branch, or at least when your feature branches last for longer than a day. So, to change my mind on this, you'll need evidence that thousands of teams build better software faster this way, and or a reasoned argument on why 2 copies of data that are changing independently of one another get easier to merge together the longer you leave them to diverge. Neither of these is going to be very likely because continuous integration is the more definitive approach at this level of explanation. Explanations based on, but I like it better, don't really cut it, I'm afraid. It's not a fashion show. The next in my list, my manager says I don't have time to do X, whatever X is. There's always the chance that any one of us ends up working for a dumb manager. But while I concede that this can be a nasty systemic problem sometimes, I think that this is always the wrong response, trying to offload this responsibility to other people. There's a choice at work here. How much of the detail of our work do we choose to expose, discuss in the context of planning? To put this another way, where is the boundary between the stuff that we are responsible for as developers and the stuff that is somebody else's job? There has to be a boundary. Obviously, we're not going to say, I spent this much time typing the letter E this week. How much time should I spend typing E's next week? This is ridiculous. So why do we do the same thing for writing tests, refactoring, or spending time on good design rather than hacking out some crap code? We software developers are complicit in this decision. The root of this problem is, and this is only my theory, probably comes from two different sources. Some of us really don't like testing very much, and don't really want to do the hard work of doing a good job of design and refactoring. So we pass the buck on to somebody else, some manager, knowing that the poor ones will say, feature, feature, feature. The other cause is that we don't really believe that testing and good design make us faster. If you're here, then I assume you'd like to do a good job, and so don't fall into the first category. So I'll concentrate on the second. Quality pays. The evidence is in. There is no trade-off between speed and quality, as counterintuitive as that may seem. If your team wants to deliver features more quickly, the only way to do that is to build higher quality software. The State of DevOps report says that teams that practice continuous delivery get high scores in both stability and throughput. They spend 44% more time on new features than teams that don't. That is, you're at least 44% more productive if you practice these kinds of techniques. That is a commercial advantage right there. So it really is pretty simple. If your manager says feature, 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 the correct response is, right boss, we hear you. We need to spend more time testing, refactoring and improving our designs because the data says that's how you deliver features fastest. Now I know that this can feel counterintuitive, but that's just your instincts and your biological drive to jump to conclusions kicking in. Science is how we overcome those biological limitations. Why is it that this is true? What's our model? Well, it's actually pretty simple. You trade off a bit of extra work now for much less work later on by focusing on the quality of your work now. By doing that, you dramatically reduce the amount of work spent later dealing with buggy or low quality code. It's not somebody else's responsibility to give us permission to do a good job. Next on my list, writing tests is a waste of time. And my code is good, so I don't need tests. Okay, at the moment when you write the code, also writing tests is clearly more typing. But if you really measure your work by the number of characters that you type, then you're doing it wrong. That aside, if you write code, you are presumably going to test it somehow, even if that test is just running it to see if it works. If you don't even do that, you should stop right now because your code doesn't work and you're a danger to others. So now the only question isn't test or not test, but what's the most efficient and effective way to test? And while running it manually or watching it executing your debugger have a place, if they're the only way that you're testing your code, you're wasting a lot of your time. It's a much more efficient work process when your development is guided by automated tests. Making a small change and running the test gives immediate feedback in seconds, rather than starting up the app, injecting some test data, and then poring over the results thinking, why on earth did it do that? In addition to all of that, the impact on the quality of our code of designing for testability is profound and goes much deeper than just having a test to show that it works. Testable code is more modular, more cohesive, and has better separation of concerns. It also hides information and is more loosely coupled. These are all properties of high quality code, and these properties give us the ability to manage the complexity in our code, as I describe in my new book. Next in my list, you can't do code review with continuous integration. Yes, you can. Of course you can. Pull requests aren't the only way to do code reviews. Pull requests were invented for open source projects, where you want to gatekeep changes from people you don't know and don't trust to change the code safely. If your team works like that, you have bigger problems than code review. Here's a thought experiment. Imagine for a moment two teams. In one team, all of the members are confident and competent enough to commit changes safely. They take care to do quality work. In the other team, some members can't be trusted to work safely, so must be monitored closely. Now think for a moment in idealistic terms. Which would you be the nicer team to work on? Which the more effective? I think that most people would prefer the first team. So, what would it take to grow a team that worked like that? Well, gatekeeping people's commits is slow and inefficient, and more than that, it doesn't really teach people how to do a better job. My preferred way is to address these problems with pair programming. Pair programming gives us a better code review than code review alone. It doesn't slow the process down, so there are no stores of code sitting around waiting for review somewhere. If the pair agree on the change, they commit it. If they don't agree, they don't commit it, and they discuss the problem and fix it and then commit it. This has a more subtle and ultimately more important effect though. As well as getting the code review, we're also involving even junior members of the team in the process of thinking about changes more carefully. At the point when they make them, not sometime later. This is a much better way to learn how to take responsibility for their changes and the importance of doing high quality work. There is good data on the effectiveness of pair programming too. I've put some links in the description below. Next, okay, these ideas may work for simple web apps, but not for my system. Well, I'm afraid that that's simply ignorance speaking. Google has 25,000 developers working in a single shared repository. They run millions of tests every day, store billions of lines of code in that one big repository, and deliver feedback on each commit to each developer in minutes. I was part of a team that built one of the world's highest performance financial exchanges. The whole enterprise system was built from day one and is still developed over a decade later, running continuous integration, test-driven development and continuous delivery in the way that I describe on this channel. We practice trunk-based development on everything, including solving some world-class difficult problems. And we produce the highest quality code base for a big system that I've ever seen. The techniques that I describe are also used by Volvo Trucks, Tesla, SpaceX on US military programs. The global telecoms giant Ericsson are rolling out their entire 5G network using continuous delivery. AAA games, banking, finance and newspaper systems are built this way. So there really is no kind of software for which this doesn't seem to apply. And it's not just for simple web apps. Last in my list, we've always done it this way and it works for us. Well, that's nice, but wouldn't you like to be able to do better? If we never question our approach and practices, then we'll never improve. The ideas that I describe here are backed by experience in companies of all kinds all over the world, working on all kinds of problems. They're backed by data that shows that this way of working is more efficient and produces better results. And they're backed by good explanations that can describe why they work. But I guarantee that in each of these organisations that I've talked about, they're also always looking for ways to do better. That's part of this approach too. So if you really want to challenge these ideas, come up with some better ones. I and many other people will be delighted to adopt them. But they do have to be at least as good as what we already can do. And to be honest, what we can already do is a lot better than many, maybe even most organisations and teams accept as normal. I think that what we're talking about here is the difference between real engineering and not, between applying a scientifically rational approach to solving practical problems in software and not. And part of that approach is always having an open mind, that there may be a better way, but not simply adopting every new idea because it feels nice or because somebody famous likes it.
This is almost certainly a provocative question. Not because there's anything wrong with either one of these things in the right context, but rather because there are times when we find people playing at development when they shouldn't be. I started out purely as a hobbyist. I'm largely a self-taught programmer, and I started out first writing simple games in the early days of home computers, and later got interested in more complex computer graphics. I spent a lot of my free time exploring computer graphics of all kinds, and then got into building 3D graphics, animation, rendering and ray tracing systems. I did a lot of playing with computers in the early days, and I think that this helped me to begin to establish some of what I'd now think of as the foundations of my coding style. I got to the point in my love affair with coding that I thought, wouldn't it be great if I could do this for a living? I couldn't get a job as a professional programmer at first. I didn't have the right qualifications for that. Instead, I got a job in support for a computer manufacturer. As part of that, I carried on writing whatever code that I thought of or interested me to solve the problems that I came across, though now I was being paid for it. I was fortunate in that my employers encouraged me to explore the systems that I was supporting. Some of this code got noticed and was used by the company that employed me for a variety of different things, and this was my route into professional programming. Before we go any further, let me say thank you to our sponsors. We're fortunate to be sponsored by Equal Experts, Tricentis, Transfic and Roost. They've all supported the channel, and all of them offer products and services that are well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, then click on the links in the description below to check them out. So the first distinction that we could try to make between hobby programming and professional programming might be about who comes up with the ideas. But I don't think that this is a good or a useful way to think about this. Often useful, important software does start out as someone's personal project or idea, even in big successful companies that are sometimes focused on other things. Software developers are in a unique position to see problems that other people miss and to see solutions that other people haven't thought of. So I don't think that this explanation is really good enough. I think that the difference may be significantly more subtle and more important than that. One of the overly simplistic approaches to software development that I see in lots of organisations is the over-specification of solutions to development teams, with sometimes non-technical people, sometimes more senior technical people, dictating solutions rather than leaving that to the people who are really in the midst of the code. I think that this is a big mistake, as I've said before here. Software development is about solving problems for people, not just transcribing predefined solutions into code. I'm not really sure where this sits though on the hobbyist professional continuum, but I am pretty certain that this is not what successful professional software development really looks like. If you're interested in more of what I do think professional software development looks like, sign up to our mail list where we publish regular free guides on all aspects of software development and regularly have special offers on training courses. There's a link in the description below to that. Ultimately, the real difference between being a professional programmer and being a hobbyist is that someone else is paying for your work. This is pretty obvious at one level, in that one of the meanings of professional means being paid to do something. But I mean more than that when I describe it that way. If I'm working on building something, even if it was my idea to start with and I'm being paid by someone else to do it, then to some extent I've abdicated some control and some responsibility for my ideas and my work. But not all control and not all responsibility. I still have a duty of professional care and a professional opinion about my work. But if I have customers or employers, then they certainly have some stake in my work too now. This is completely different to when I'm writing code for my own self-interest and has some significant implications for how I'm going to behave. I mentioned earlier that in my early steps as a developer, I got very interested in computer graphics. I built my own tools and libraries, and this was before the days of graphics code processors. So I built the entire stack from writing code to map and render pixels on the screen and drawing graphical primitives like lines and arcs in assembler to, in the end, a full 3D modeling package that did ray tracing and some basic physics in constructing animated models. The lower layers were pretty decently refined because I used them everywhere. So over time, I refined them to make them easy for me to use. But the closer I got to the edges of my understanding and learning, the less refined the system was. For example, I built my 3D models with some loose collection of very crude tools. I often wrote bits of code to generate bits of the 3D models as I needed them. This was because I was the only user, and so this was perfectly fine for me. I had ideas and plans of how to make the 3D modeling problem easier, but I never got around to that part of the problem because I was interested in the other parts, the problems of rendering ever more realistic versions of the animations I was trying to create. Remember, this was a long time ago, so the animations weren't really very realistic by today's standards. This would have been a very bad idea if I'd been doing this as a professional though. I was a professional by this time, but this project wasn't what I was being paid to do. I now think that if I'd worked on this stuff as a professional, I would have certainly been doing the people that paid me a disservice if I'd kept working in this way. But actually, I would also have been doing myself a disservice too. The difference here is really about what is the goal of my work. In my exploration of the graphics programming problems that I found so much fun was solely about my own learning. I was exploring for fun. I learned a lot by focusing on trying to build better and better animations. Later, I benefited from this learning in a wide variety of ways, but these other things were never my direct motivation at the time. Fairly early on, I sold one of my games. It wasn't a huge success, you won't have heard of it, but even so, I now had to do a lot of work on other kinds of things that I hadn't bothered with when I was playing with it for my own ends. I had to add front screens and proper scoring systems and other stuff that I hadn't really cared about up to this point. I hadn't even bothered to add any support for text in my first version of the game when I was only learning about how to better manipulate the graphics. I was chatting to a friend about this recently, and she made an analogy with musicians. Amateur musicians do it only for the pleasure. They practice to learn new things and to push the boundaries of their knowledge. Many people who do this will leave quite significant gaps in their understanding and their practice as a result, because they're doing it for fun. Professional musicians practice for a very different reason and with very different goals. There's an old saying about professional practice in music. Don't practice it until you can play it right, practice it until you can't play it wrong. That's a very different perspective. When I'm working in hobbyist mode, I'm playing. I may be playing with a goal in mind and focused on learning new things, but this is more like noodling on the guitar or jamming along to the adverts on the TV. My learning is only loosely directed. I may gain skills through this kind of practice, but my goals are pretty general, and this isn't the best way to hone my skills really. I believe that ours is a profession that is foundationally grounded in our ability to learn. I think that to become effective professionals, we must take our skills at learning seriously. So I certainly don't mean to dismiss the importance of learning here, but the learning that we do as a professional is somewhat different, I think. Our learning is, or should be, more directed. We're learning a specific technology, perhaps for a particular goal, or we're learning about the problem that we're solving to better understand and shape our solutions. We may decide to learn something completely new, a new language or technique, but like the musician, our aim is to do that in a way that helps us to limit our mistakes later on. So we'll still be more cautious about how and where we apply our new skills at the limits of our knowledge than we were when operating as hobbyists. Why does any of this matter? Well, I think that each of these styles of development have their place, but I see people suffering from misapplying both in the wrong contexts. If you're a hobbyist and you're focused on building something as a professional style development, I think that you might be missing out. You'll be spending too much time on stuff that isn't really teaching you anything new. So in these circumstances, your goal should be to focus on what it is that you really want to learn and play with the ideas enough to learn it, or at least have fun while playing. This isn't really the real problem though. Let me be clear. I think that the much more common problem is usually the other way around. People working in a professional context, but working as though they were hobbyists. The problem here is not that we don't need creativity or that professional development should be formulaic. Neither of these things are true. But what is true is that in professional development, not everything is creative and groundbreaking. Not everything is always huge amounts of fun. There is stuff that we must do to satisfy those people who've invested in our skills in some way. Ultimately, we have to build things that people want, even if they don't know yet what it is that they want. We have to build things that people can use, at least to the extent that the people that use them can make progress of some kind. One of the mistakes that I see quite often in some kinds of hobbyist development teams is, well, here is our wonderful product, platform or service. If people can't figure out how to use it, then that's their problem. They need to try harder. Maybe learn our special programming language or arcane API. After all, we can use it, so it must be usable. Well, just because you can use it after you wrote it doesn't mean that anyone else can sensibly do so. This problem is relatively common in open source projects that neglect the documentation, for example, because that isn't the fun part usually. This is fine if you don't care if your project is used or useful. But now you're doing this for yourself rather than to help other people, which is fine, but know which one you're doing and choose the right strategy. This is to me a clear example of a hobbyist mindset, one that is internally focused on the pleasure of the development team, rather than being focused on taking the perspective of the real use of the code or system by other people. Sure, this may not always be the fun part for you, but there are only two strategies here. You either make something from the perspective of your users, or you make something to gratify the development team. Either is fine, but if you only do the second, you're playing at it. If you're making things for real users, you need to do the extra work to make it easy for them to use and understand. This means that you must spend time on things that aren't always the fun part. If you've ever complained about the need for meetings, for example, then what does this really mean in a professional context? Do you expect to work alone on only the things that you think of? If not, then you'll need to meet with other people to discuss things sometimes. Most people hate useless, poorly focused meetings, but meetings are an essential part of working as part of a team. I once had to write a report on a project that the consultancy that I worked for at the time had done, and that had been a bit of a disaster. It had gone wrong for many reasons, but one of them was that the project management at the client had done some really rather dumb things. Someone had decided that developers were only really working when they were typing. So they had banned all meetings. Even two people talking together was not allowed. They had a deadline to meet. It got so bad that the development teams were sneaking off to hold meetings in the toilets. So be careful what you wish for. Professional development is about collaboration, and that means we need to talk. And you may not think of it this way, but these talks are meetings too. Meetings aren't automatically a problem, bad ones are. Railing against all meetings is one of those signs of a hobbyist group to my mind. So if your meetings are a problem, fix the useful ones, make them better, and eliminate the ones that aren't helping. The other hobbyist tendency that I sometimes see is people avoiding the grungier parts of the job. In the best teams that I've seen, the ones that I think of as being really successful professional teams, people are happy to contribute even if it means working on the less glamorous bits occasionally. I and two of my colleagues once spent a month trying to figure out different approaches to optimizing build scripts. On another big project, we had a team of 3 people who spent months porting changes between 3 different branches in order to be able to enable a much more glamorous big refactoring exercise that was needed to pay back some technical debt. This work was intricate, sometimes quite complicated, not very rewarding to be honest, and sometimes even boring. But it was essential to unblock the work of over 200 other people, and it worked. It was bad enough that we rotated people through this small team to share the pain, but one person stayed for the whole time to see it through. He was instrumental in saving the project, in my opinion. On yet another project, we had a complex data migration problem that we hadn't really nailed yet. During this time, while we were figuring it out, one of our teammates oversaw the migration every time we did one. Once per week, manually checking and sometimes correcting more difficult parts of the migration to keep us going until we nailed the automated version. As I said earlier, this kind of work is not really very glamorous. People rarely talk about this kind of thing at conferences or write books about it, but these sorts of tasks and lots of others are the hard yards of professional software development. Of course, we want to try to automate as much of this stuff as we can, but even the task of automating these things is often not really what most people think of when they imagine the exciting bits of their job. I think that one of the other differences between being a professional and a hobbyist is maybe the ability to take pleasure from doing a good job of the less than glamorous stuff, as well as the obviously more exciting things. I wonder if this may be down to a stronger sense of professional pride in those people. Certainly, from my own perspective, while it's nice to work on the cool bits of a system in a field that you find exciting and interesting, I find a lot of pleasure in just doing a good job of solving the other stuff well too. If I can find what I think of as a smart way to solve a problem, it doesn't really matter too much what the problem was, to be honest. If I feel that I have a good solution, even with boring technology, and if I feel that I have helped the team, even if they don't really notice how I did it, I can take a lot of pleasure from that, satisfaction in a job well done. Whether I was writing a simple script, organising some data, or designing the core of something more important. Of course, like everyone else, my preference is to work at the core of something important. But if I'm honest, I interpret something important as meaning something of value to other people, not just something that's exciting to me. Thank you for watching. I know that this was a little different to what you normally expect from us here, but I hope too that you enjoyed it all the same. Please do subscribe and like if you haven't already, and if you did enjoy the content today. Also, you might want to consider joining our Patreon members. Our Patreon members get lots of exclusive perks. There's also a lot of useful information on our training site, including detailed free tutorials as well as paid for training in modern software engineering techniques. I hope to see you here next time. Bye-bye.